To reinforce how inheritance works, I've added an example to the Gaussian class code. I've written a new Python class called distribution. This class is going to be the parent class of both the Gaussian class and the binomial class that you are going to code at the end of the lesson. A lot of the code should look familiar. The init function was the same as the Gaussian init. I've simplified the read data file function so that it only reads in a data set, whereas before this function also calculated the mean and standard deviation of the data. The Gaussian class code has changed slightly. Now the Gaussian class inherits from the distribution class. The init function uses the distribution's init function. Scrolling down, the read data file method is still in the Gaussian class. This is because I wanted to override the read data file method from the distribution class in order to calculate the mean and standard deviation. Even though the code looks a little bit different than before, the Gaussian class works exactly the same way as it did before. It might seem like the changes in the code are superficial, and I'd agree with that. I mostly wanted to introduce inheritance so that you could recognize the syntax. Near the end of the lesson, we're going to look at the source code for scikit-learn. A package like scikit-learn contains many classes that use inheritance. You'll have an easier time understanding the syntax now that you've seen how inheritance works. I've provided this distribution and Gaussian code for you in the next section so that you can play around with it. We're getting close to the end of the lesson. The next step is to modularize all of this code into separate Python files. Then you'll see how to make a Python package. And the last steps will include extending the code to include a binomial distribution and uploading the code to PyPy. So let's start by modularizing this code.